Hello, this is the third in a set of 3 presentations about hyperbolic functions. In the first presentation, we looked at the origin of hyperbolic functions, their definitions, and various identities that connect them. In the second presentation, we looked at sketching the main hyperbolic functions and deriving expressions for their inverses. In this presentation, we're going to look at integrals and differentials related to hyperbolic functions and conclude by explaining why the functions are named as they are. Let's start by defining y equals sine x, which by definition is e to the x minus e to the minus x on 2. Differentiating, we get dy by dx equals e to the x plus e to the minus x on 2, which is cosh x. So the differential of sine x is cosh x, which is also a result which we came across in the second presentation. Now integration is the reverse of differentiation, so we immediately know that the indefinite integral of cosh x with respect to x is sine x plus a constant. Now let's define y equals cosh x, which is by definition e to the x plus e to the minus x on 2. Differentiating, we get dy by dx equals e to the x minus e to the minus x on 2, which is sine x. So the differential of cosh x is sine x, another result which we met in the second presentation. And so the integral of sine x is cosh x. How about tanh x? Well, tanh x is, by definition, sine x over cosh x. We can differentiate this using the quotient rule. Bottom times differential of top minus top times differential of the bottom over the bottom squared. In this case, it's cosh x times cosh x minus sine x times sine x over cosh squared x. Now we have already met the identity cosh squared x minus sine squared x equals 1. So this simplifies to 1 over cosh squared x, or sech squared x. So the differential of tanh x is sech squared x, and therefore the integral of sech squared x is tanh x. But what about the integral of tanh x? Well, notice that the numerator, sine x, is the derivative of the denominator, cosh x. There's a standard result in calculus that says that the integral of f dash of x over f of x is log absolute value of f of x. So in this case, the integral is the log of the absolute value of cosh x. But cosh x is always positive, so the absolute sign is not needed, and hence the integral of tanh x is simply the log of cosh x. We can use exactly the same approach with coth x. Differentiating cosh x over sine x using the quotient rule gives sine squared x minus cosh squared x over sine squared x, which is just minus 1 over sine squared x, or minus cosech squared x. That, of course, tells us that the integral of cosech squared x is minus coth x. To integrate coth x, we write it as cosh x over sine x. Once again, we see that the numerator is the differential of the denominator, and therefore the integral is simply the log of the absolute value of sine x. Notice that the absolute signs are needed here, because sine x can be negative. Now let's move on to differentiating inverse hyperbolic functions. Suppose y is the inverse sine of x. Then sine y equals x. Differentiating with respect to y gives dx by dy equals cosh y, and therefore dy by dx is 1 over cosh y. Remembering that cosh squared y minus sine squared y equals 1 means that we can write this as 1 over root 1 plus sine squared y, which is equal to 1 over root 1 plus x squared. To summarise, the differential of arc sine x with respect to x is 1 over root x squared plus 1. We can use the chain rule to differentiate arcsine x over a to give 1 over root x over a all squared plus 1, all multiplied by 1 over a. This simplifies to 1 over root x squared plus a squared. And from this, it follows that the integral of 1 over root x squared plus a squared is the inverse sine of x over a. Now let's define y equals the inverse cosh of x. So x equals cosh y, and therefore dx by dy equals sine y. So dy by dx is 1 over sine y, and because cosh squared minus sine squared equals 1, we can write this as 1 over root cosh squared y minus 1, which is 1 over root x squared minus 1. To summarise, the differential of arc cosh x with respect to x is 1 over root x squared minus 1. We can use the chain rule to differentiate inverse cosh of x over a to give 1 over root x over a all squared minus 1, all multiplied by 1 over a. This simplifies to 1 over root x squared minus a squared. Consequently, the integral of 1 over root x squared minus a squared is arc cosh x over a. Lastly, let's consider y equals the inverse tanh of x. So x equals tanh y, and therefore dx by dy equals sec squared y, which is 1 minus tanh squared y, which is 1 minus x squared. So dy by dx is 1 over 1 minus x squared. In other words, the differential of arc tanh x is 1 over 1 minus x squared. The chain rule then tells us that the differential of arc tanh x over a is 1 over 1 minus x over a all squared times 1 over a. So the differential of 1 over a arc tanh x over a is just 1 over a squared minus x squared. From that, we know that the integral of 1 over a squared minus x squared is 1 over a inverse tanh of x over a. That concludes our examination of differentials and integrals. To conclude the presentation, I want to answer the question, why is the function e to the x minus e to the minus x on 2 called the hyperbolic sine? Why hyperbolic and why sine? By way of introduction, let's define a curve parametrically as x equals sine t and y equals cos t. Any value of t defines a point, xy. But what curve does this form when we consider all possible values of t? To answer that, we square both equations and add them to give x squared plus y squared equals sine squared t plus cos squared t equals 1. This is the equation of a circle. 1 is the parametric equation of a circle, and that's why sine and cosine are referred to as the circular functions. Now let's define x equals sine t and y equals cosh t. As t varies, what curve do we trace out? Squaring both equations and subtracting gives y squared minus x squared equals cosh squared t minus sine squared t, which equals 1. The equation y squared minus x squared equals 1 is actually the equation of a hyperbola with asymptotes y equals x and y equals minus x. Now we have the answer. As we saw in the first presentation, sin x is related to sine through the identity sine ix equals I sin x, and it is related to hyperbolas as we've just seen. Hence the name hyperbolic sine. Cosh is similar. Well, I hope you found these presentations interesting. If you have any questions, drop me a message below, and if there are any other topics you want me to cover, again, just let me know.